Hardly push that thing. Okay. All right, so we're going to put in the y because we know we're going to need it. So ln x over x squared. So fraction, oops, I'm not sure why I did that, but ln x, don't forget to close your parentheses, over x squared. Remember, the calculator will read this differently if you don't put in parentheses, so make sure you do. And right below that, if we're sure about our derivative, we could do this, but like Cindy said, I'm not really sure about that, then you could do this. Math, 8, with respect to x, the derivative of, in this case, I'm having y1, y2 rather. I'm taking the derivative of y2, right? With respect to x, that will be the graph. We'll put a value in there because you don't want the one value, you want the graph. Bars, variables, and then do the right. Okay. No, I would do that on the home screen. I wouldn't do that in there. Yes. Yes. Well, okay. Well, hold on. All right. So we are going to check. We are looking for a value between 1 and radical e. Okay. I just shrunk it so it was shrunk it. Okay. So first of all, let's figure out what radical e is, shall we? Okay. So that's 1.648-ish. All right. So what's the number between 1 and 1.648? Okay. So we can do, you can set up your table, you can do your value. Now, if you just want, you need a derivative, you're talking about testing derivative, right? So let's show Abby when we could use this. Math, 8, x, I put in mine for y2.
Pardon this interruption, this is program 108.
Sorry!
Thank you.
You're welcome. I thought about it.
You broke your stretch.
I know it's, Hannah, don't be disappointed in me.
I'll try not to go home and cry.
Yeah. Wait, Miss Silver, why do I have a medical thing by my name? Are you
It's whatever. I can look at it later. You may not want to know that you're seeing a psychologist first. Sometimes it's whatever your mother put in your medical report. It'd be like, sometimes it's as benign as she needs to take Motrin when she has her period. You're kidding. Like, really, would you ever put that out there? Anyway.
Because if you don't put that, they won't give you anything.
Yeah, they'll give it. So you put it in your purse.
I have a bottle of Tylenol and Prozac that I keep.
She will literally rip you apart. She's like,
I have medicine in your purse. You need to give it to me.
it's over the counter.
Yeah, but you're gonna
They
like.
like,
I mean, we can tell them, like, we can do it without telling them it's in their bag.
It's like in the bag. Who knows?
Oh my God, I'm sorry.
Molly, help me. Okay.
I'm recording, man.
Okay, so there we go. We're going to put in the derivative at 1.5, y'all said, right? All right. Is it positive or negative? Positive. Okay, so I'm going to put F positive at the top. I'm just going to put positive. I'm just going to put positive. What's in between 1.648 and 3? 2. Okay. So here's what I'm going to do. Save yourself some time. Scroll up.
Oh my God.
Grab it. And then replace this with a 2.
Yes.
Oh, man. Not there. 2. Delete.
That's
Okay.
Oh,
That's right. Negative. Okay? All right. So, stop. Stop. What do you know here right now about local max or min?
There's a max. Radical E.
What is it?
I haven't said that.
Whatever you
It's 0.1839.
okay?
I think. We'll double check
It is the F of radical E, right? Okay, we're gonna have to do that anyway later. I don't want you to put X equals radical E. I want you to put, if it asks for the local max, I want you to put the maximum values, okay?
You want us to put it in order pair, or do you want to
I would be happy with that. Okay, so second trace, I'm doing a graph. First, I'm going to shut this one off. Do you know how to shut off an equation? Equal sign, enter, okay? Because otherwise, it will graph it for you, and you don't want to. So radical E, I need a value. Okay, so it'll graph that. Remember how slow the derivative? Okay, so radical E. There you go. 0.184, right? 3 is the minimum, but 4 is good too. Okay. All right, now that's new problem. Absolute. Now, talking about endpoints. F of 1, F of 3, and we also found critical values between 1 and 3. The 0 again is not going to count. F of radical E, which we already know is 1.184. Okay? All right, do the same thing. Your calculator's already ready. All you have to do is put 3 in. Okay? So what's 3? Wait, 1, 2, 2. Okay? No, this is the F. Yes. And then put in a 1, and you have 0. Okay. So tell me what is the absolute max? No. What is the absolute max? It's either this one, or this one. 0.184.
Oh my God.
And that's the X value. I want that one. That's why I'm being so weird. Coordinates? Not coordinates. Okay. Absolute min is what?
0 at F of 1.
Okay. At X equals. Okay. All right. F of 1 is 0. Okay. So, and the reason I have to be real weird again is, remember, it's multiple choice sometimes. So they're not going to have, they're going to have that as an answer, but that's not the absolute max. That's the X value, the absolute max. That's not the absolute max. Absolute max is really the Y value, just to be clear.
They're trying to trick us.
They may. They like you to know your language. All right, so what's next? After 6. 11 was the second scale.
Okay. 11 times the back of the
All right.
The back of the answer. Because they was trying to compensate for.
You'll just talk over me.
I'm
I'm just trying to shut you. All right, Cindy, tell me what the Y prime is, because I already got this right.
Yeah, 2 sin of x times cosine of x. Like cosine of x plus 1 is in parentheses.
Is there another sign in there? She's just
I'm
she's putting it
fine.
before
I'm
distributed.
2 cosine of x sine x plus 2 sine x.
Okay.
And then I distribute.
And then you can factor. Everybody get that? Y prime? Yes? Okay. And then she factored
2 sine of x parentheses plus
minus 1.
sine.
It is plus. Yes. Okay. So there's your Y prime, whichever one you want. All right. So we need some critical values. Where do we find those, Hannah?
When that your Y prime is equal to 0 or does not exist.
Okay. Very good. Don't forget about this, girls. Does that, in this case, you could forget about it and be okay, but not always. Okay. So how do I get this equal to 0, Emma?
What am I trying to say?
Put 2 sine of x equal to 0 and cosine x plus 1. I'm just like divide it up, but then
Set the factors equal to 0.
Yeah.
That.
Sine of x equals 0. Where does sine of x equal 0?
0 and pi.
0 and pi. and 2 pi, and 3 pi, and blah, blah, blah.
Let's just go to
Okay. Over here, cosine of x equals -1, where's that? And 3 pi, and 5 pi, blah, blah, blah. Okay?
So pi.
All right. Now, so those are our critical values. Probably don't want to do the second reading test. I was thinking maybe that'd be easier because we got so many things, but it's probably not good because we have to, okay. So we're gonna interval test. All right, so we made an executive decision. Let's say we're gonna go to, for just this problem, -pi to 2 pi. How about? So we talk about the negative values, okay? If that's not there, then it will be, but for the most part. Okay, so -pi is a 0, right? That would be one of these guys, right? -pi is the same value as pi, right? Okay, we're going to start there. 0, pi, 2 pi. Okay, so here's all my critical values. All right? Now, you can put that in the calculator if you think it'd be quicker. Let's just throw some -pi/2. What's between 0 and pi? Pi/2, between pi and 2 pi, 3 pi/2. Now, the beauty of 3 pi/2, it's the same value as -pi/2. So if you've got that covered, once you do it once. All right, we're going to check into this right here. All right, 2 sine of pi. What's sine of -pi/2? -1. So that's going to be negative, right, this piece? Okay, and then cosine of -pi/2 is 0 plus 1 is positive, so this is going to be negative, right? Everybody catch that?
Yeah.
All right, pi/2 is up here. Okay, so 2 sine is going to be positive or negative? Positive times positive, so that's going to be positive. And this is also going to be negative, right? All right, and we're done. We quit at 2 pi, just for convenience. Okay, so do we have a max here? Local max at x equals pi. Okay, and we'll go back and figure out what that is here in a minute. Local min, x equals 0. Is that it? But we didn't go, we're just stopping at 2 pi. Okay? All right, what is my local max? Okay, that sounds like a plan. What are we plugging into? The original problem. Sine squared of pi. What's sine of pi? Okay, so that's 0. Minus cosine pi is -2 times -1. So that's 2. Okay. All right, and the local min is at 0. Sine of 0. 0, right? -2 times so -2. Okay. All right. So we have that. All right. Now, we adjusted this problem, so we want to keep the adjustment for the absolute max. Because otherwise, let's just pretend no. Okay? No closed interval. Okay? Because that is going to come up. So all that means is that we're not guaranteed an absolute max. So critical values, what were they again? 0, pi, 2 pi, 3 pi, so on and so forth. Okay?
You have more than one episode.
Yes. Yes, you can. Okay, f of 0, f of pi, f of 2 pi, f of 3 pi, f of, there'll be some pattern here probably if you can state this. All right, so f of 0 we already did, it seems like. It was -2, right? F of pi was 2. F of 2 pi would be at the same value as f of 0. 3 pi would be, okay, so on and so forth. Okay, so let's say this was the, we have absolute max of 2, right? Okay, see, and this takes care of our problem where well, it's at 0, it's at 2 pi, it's going to be at 4 pi. So we don't have to say that if we can just say the absolute max is 2, right? And the absolute min is negative 2. Okay? Yeah. Okay. Alrighty then, what's the next one? Well, we did absolute and local, so we're done. Oh, step 11, oh man. Yeah, okay. I knew 11 was gonna be. Okay. Alright, vertical, horizontal asymptotes, none, right? When are you gonna see vertical and horizontal asymptotes? What are your fractions? That's right. Okay, good job. Alright, intervals of increase or decrease. We got that. Local max and min, concavity, we didn't do that. Okay, let's do that, just because we haven't done that yet. F double prime.
Prime is 2 sine x plus sine x plus 2 sine x.
Okay.
I don't think 2 sine.
Plus what?
2 sine x.
That's a single column, right?
That is simple.
Okay. So who's confident about your double prime here? Go ahead, Alan.
2 cosine squared x minus 2 sine squared x plus 2 cosine x.
Okay. Did you get that? Allie, wherever she get that? Okay. We had to do a product rule here. Okay, now, we've got cosine squared and sine squared and a cosine. So we probably, in order to solve this and get super critical values, we probably want to do what? To solve. We can't really factor with a cosine squared and a sine squared in there. We'll pull out a 2, sure. Not what I had in mind, but that's a good start. Can you do what?
Wait, aren't those just
Wait.
Can you combine cosine squared x and negative?
Yeah, you know what it is.
Cosine 2.
Mhm.
That help you out?
I don't know that I would do that, but that's correct. Because, yeah, and that's exactly right. Sometimes you think of something and you're like, will that help me? Not really. Okay, so what else could we do? Okay, that sounds like a plan. 1 minus cosine squared is sine of x. Now, y'all remember that, right? From sine squared plus cosine squared. Okay, so what is that? 2 cosine squared minus 1 plus cosine.
Oh, yeah, it is. You took out the 2 first.
Was Lindsay's idea. Okay, so this all equals 0 or doesn't exist, but it does. It's not going to not exist, right? Cosine exists everywhere. All right, so factors. So our only options, this needs to be plus, so this be minus. Okay. Set our factors equal to 0. Cosine x equals 1/2. There is cosine x 1/2. Pi over 3 and fourth quadrant. 5 pi over 3. Cosine of x equals -1. That's over at pi and 3 pi, etc. Okay? Yikes. Okay. Yeah. Okay, so let's, okay, this is our, so what do we have? I'm gonna go to negative pi to 2 pi again, just so we can put it. Here's 0, pi over 3 would be about right here. One of your critical values, 5 pi over 3 about right here. Okay. And pi? We missed pi? Okay. I know, but I was thinking what we did this morning. Okay, I'm gonna put this in the calculator again.
We didn't have
I'm gonna put this in the calculator again just because I'm feeling lazy. All right, so I'm gonna put this double prime in the calculator. Okay, so what is it? 2 cosine x. Oops, I forgot to square it. Okay. Squared. I'm putting plus cosine of x. Don't forget to close your x. Okay. Then I'm going to do a value here. Yeah, I don't have my window set up like I should, but I think it'll still work. Okay, now we got our zeros here, here, and here. So tell me a number that I can put in. I could do 0, right? Okay. What about between pi over 3 and pi? Pi over 2, okay. And between pi and 5 pi over 3? No. 3 pi over 2 is going to be on the wrong side. Because here's 2 pi, and 5 pi over 3 is here.
You're in between pi.
in between pi and
3 pi over 2 is here.
You're in between pi and 5 pi over 3 right now.
Oh, duh. Okay.
Yeah,
Sorry. Oh, I was thinking about this. Okay. What's in between there? Sorry.
No, it's not.
No, because that would be down here.
7 pi over 4.
Okay. All right. Anyway. Okay, so 0. And again, we're just being lazy. 2. So that's positive, right? Okay. And pi over 2. Negative 1. Okay, and 3 pi over 2. Negative again. And 7 pi over 4. Did I put it in there wrong? It's positive? I must have done something wrong. Okay. All right. Okay, so concave up here and here. Concave down here. Okay, if this is a supercritical number, right here, pi, it's a critical value for double prime. Do I have to split this concavity here? No. I don't. As long as you don't, as long as this is not a where f prime doesn't exist, right? Okay. So where's our inflection points? Pi over 3, because we went from positive to negative, and right here we went from negative to positive. And there's no differentiation like there is with the local maximums. It's just when the concavity changes are the inflection points. Oh gosh, yeah. Okay. Well, I wanted to give you and I knew it was ugly, yeah. I knew it was going to be ugly, but I wanted to give you one with some trig. That was pretty intense, but we all survived, so it's all good. All right.
Did we survive?
You survived, you're all here.
I'd rather you give us harder ones than I'm telling you.
That's right. Thank you, Emma.
You didn't close your sign for it.
Thank you. I know it looks weird. Nice. 2%. All right. Let me set my window to negative pi, because that's kind of what I was looking at, to 2 pi. All right, that's good enough. I'm not getting above negative 2 to 2, so. All right, let's see how that works. Let's see if the concavity works. Certainly, we get at negative pi, we're supposed to be concave up. Why does it look concave up to me? This looks concave down right here, and this looks up. Is that what we did?
What?
Am I saying it wrong?
Yeah, you're saying it wrong.
Okay.
Starting at from negative
To about right.
2 pi over 3. You're going concave up.
So they call all this to about right here, probably concave up.
I don't think so. I think because in the back they had it like 2n plus 4.
Well, don't worry about that. We just stopped the 2n business.
I think it would change on like negative.
I think it would too, because it would go this way.
I just-
Okay. And we really only tested it to 0, so let's just talk about, let's just go here, make sure the rest of that makes sense. Okay, so right here we are concave what? What are we supposed to be?
Up.
That's right.
Okay.
Well, concave
You're
up.
just supposed to
I'm
be
sorry,
valued
All right.
0 and then
We're not-
This is concave up,
Right.
okay? Then this is concave down. Remember, we don't have to split that. We talked about that. And then we got concave. All right, we're good. Okay.
What's that position?
Oh, well. Okay. What's next?
36.
36. Just the answer. Hannah says, on already. 36 is a related rate. How does 8 over 9 pi grab you? Okay, hold on.
We do not nine. Wait.
The answer, the decimal is, that sounds like 0.2829.
So I got 0.88 on.
Yeah. Oh,
Did it? Yeah. Okay. Get it right, Hannah?
Nope.
Oh, man. Yes.
What the way through it?
That I did. Where did you get a? Oh, I see. Did I just drop it?
But volume,
Oh, I think I did a DVD too.
I honestly think I
The
dropped the
volume
bottle.
change. I didn't do a DH.
okay.
Oh,
This you gotta be careful of, because if you do your standard 8 divided by 9 pi like that, the calculator is not doing this. It's doing 8 divided by 9 times pi.
What it is, I think I called what they did, like, they did a change of the, like, volume. But I called that the change of the height.
It's a 0.23. Oh, I did it right.
Okay, do we need to do this?
No, I think I
Okay. You gotta do a proportion down here, right? R's to H has 3 to 10.
I know what I did wrong, but you did wrong 10 thirds.
Did you do H over R or R over H? Okay, well, there you go. Does anybody need to keep going? Anyone? I don't mind. Yep. Okay. What do we know, Lindsay? You know dB/dt, I think, right? It's 2. Okay. That's what I mean by what do we know. What are we looking for? dH/dt? Okay.
No,
And that's when H is what? 5? Okay. We know anything else? I think it's good. Okay, so we're going to have to get rid of our R, right? All right, so what's R over here? 10R equals 3H, so R equals 3H over 10. Did you do that right? Okay. So if you got to that point, you can do it from there. Yeah. Okay. Let's do a new problem. I'm tired of this. All right. Let's go to
40 and also, do they have 2 in the back of the book? With all of them?
It's just so long.
what? Did you not get 40?
Well,
Number 40, what was the answer? Is nearest point is 4, 2.
No,
Nope.
not at all.
Okay. We got x equals 8. And we're trying to look the closest to what point? 3, 0? All right. Did you graph it?
I did.
I did this 30 minutes with
Okay, so this is, if you graph it, just do this, and this will be it. Okay? 3, 0 ends up being where? 1, 2, 3, about right here. So we want to find this distance, and what are you calling it? Oh, what a great idea, you think. X, Y. Okay, the distance between 2 points, remember, is
the radical and then parentheses x minus 3 plus parentheses y minus 2. Squared.
I'm trying to do that one.
x minus 3 squared plus,
Y minus 0.
all right. Now, y, let's swap him out. What's y?
8 over x.
Okay,
So
8 over x squared.
X.
I don't know why I just put it over there, but anyway. Okay, so far so good? All right, now, we are looking for the closest distance. We can look for the closest distance squared, and that would be okay, right? Okay, so we'll call that m for minimum. X squared plus 64, x to the minus 2 minus 6x plus 9. All right, closest is minimum. How do we find, where are the minimums going to, where are they going to happen? Critical values. Okay, and endpoints. Do we have endpoints? No. Okay, so critical values, where you can find critical values. What doesn't exist or equals 0?
When you're F prime.
Okay, so m prime equals 2x minus 128x to the negative third minus 6. Is that right?
Yeah.
Okay, critical value, 0. Let's see. 2x minus, I'm going to put my x to the third back down, minus 6. Okay, now what?
So can you just get rid of the radical like that?
The radical? Yes, 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 you can. Because if you are closest, what the heck? If you are closest, what are you doing here? If the distance is, if this is like 3, then 9 is going to be the closest to. So if you have 2 points, and let's say this is square root of 5 and this is square root of 17. Well, if you square them, they're still the same closeness.
Explain that really badly, but you know what I'm saying?
It's the same relationship. So if it's the smallest, as long as you square it, both, your distance squared is going to be the closest distance.
So do we have to, is it just like gone?
Unless you were looking for the distance, you would have to put it back on. But you don't have to ever put it back on. If it says what is the closest distance, then you would have to put the radical back on. Good question. Okay, so how do I solve this for 0? I know x is a critical value. X equals 0, but also kind of a worthless one, right? X is a critical value, but it's really not significant, probably because that's not going to be the closest over here, but we can hold on to it. Okay, so how do I get this? This is where the derivative doesn't exist, right? Okay, I'm going to get a common denominator. Alrighty then, which would be x cubed. So what would that be? 2x to the 4th minus 128 minus, okay. All right, we were solving that. Remember, the denominator is the one that equals 0. Okay. Now, you're going to have to use a calculator to find that, to solve that, right? Okay, how do we do that? Plug, plug, plug. What do you want me to plug in? The whole thing? And then look for a what? A 0? Okay, that sounds good. 128 minus 6x to the 3rd. Let me set up my standard window here. 6. I don't want to graph it yet. 0, number 2. Okay. I know. The heck? Why is it not graphing? It's just spinning. Did you all get it graphed? Mine just wants to spin. Oh, there it is. Okay. It's a terrible graph. You know it's a polynomial. I don't really need to fix the window. I just need to find some zeros, right? Right? Okay. Second, 0. Number 2. I'm going to find this one on the left. Here pretty soon. There it is on the left, on the right, and I don't want to guess. Oh, for gosh
You went to the left on the right, you went to the right on the left.
All right, what is it? 9498. Is that what you said? Okay, what's the other one? Anybody get that one? 4. It's exactly 4. Yeah.
Oh, that first one is 949.
Okay. All right. And now what? You gotta plug in. Now, here's the thing. Use your figure. -2 point is way over here. You think that's to be closest to 3, 0? No. So at x equals 4, what's y? 8 over 4, which is 2. There's your closest point, 4, 2.
That's the only way you can find out which point to use to look at the graph.
No, you could, well, let me think. I'm eliminating the 1 because of the graph.
I mean, you know that the point is 3, 0.
Right.
You can plug them into this is what you're doing.
Yeah, you could. That's why you'd have to do it if you really didn't have the graph in front of you. Okay?
But if you know that it's like -2, whatever, and 4, 2, you know.
Right. But yeah, that's when you would have to, if you really, if say it was 4 and 5, you would have to go all the way up here, find the y that goes with it, and actually find the distance with the radical and everything to do the closest.
That's like I did with the radical and
Yeah, it gets real
it was
weird.
like really late for us.
Yeah. The whole idea is, let's say you have, let's try to get another page, a point here and a point here, and you're looking at the distance, okay? And then you have a point here. Let's say this distance was 5 apart, and this distance is radical 26. So very close, okay? Well, if you square this, you're now looking at 25, and you square this, you're looking at 26. Which one's closer? This one. The 25 is smaller than the 26, so 5 is also smaller than radical 26. That's kind of the principle that we're using. All right, any others on this homework that we need to talk about? All right, let's get out. That's all right. It was long, I know. Okay. Let's look here. No, I want to look at the study guide first. Yeah, that's fine. Thank you, though. Okay, so we got to, we talked about everything on extrema, increasing, decreasing, points of inflection, concave up and down. I don't think there's any issue except, let's talk about what they might give us instead of f of x equals blah, 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 find f prime, you know how to find increasing, find double prime, you know how to find concavity. Let's say they give you f prime like this. This is f prime, the graph, okay? I want to find where f, which is not shown, is concave up. Let me give you some values here. That's -4.
It's where
That's about negative, if you need that. So I'm trying to get some, I'll do 5, just for fun, okay? And we'll do from -4 to 5, because we won't talk about anything after this point and anything before that point. Okay, now the danger is we still think, okay, f prime, where concave up is where f double prime is positive, which is where okay, which is f prime is increasing. I don't like that though. I just don't.
but it worked.
But it works. Okay, so you get in your head where you think concave up is, and I'll tell you what I do, because this bothers me. I can make it work, but I don't like it. Can you not? Okay, shh. Okay, so tell me what you think concave up is, Miss Emma.
Yeah, I think that's kind of hard, but you could do it like at 1 maybe.
Well, is this maybe, or is this?
Well, there's no values there.
What do you need? Where do you need values from? Where?
Where it's
Negative
-1.
I mean, you need values here. Okay, there you go. What?
-4.
Okay, shh. Go ahead. Concave up.
-4 to that max.
Okay, you're still reading it like that's F. That's not F, it's F prime.
Is F prime is F prime not increasing it from -4 to that max?
F to right here?
Yeah.
Okay, so you're doing -1.5?
Yeah.
Ish, okay?
And then we're stopping at 5?
Yes. So that's concave. Okay,
So then it's concave down from -5.
okay, so it's increasing. So concave, it's concave up right here to here, to here, to here, to here, to here, to here. Because concave, F double prime is what to F prime? Slope, right? That's what I'm doing. Positive slope, positive slope, positive slope, 0. And then negative slope, negative slope, negative slope, 0. And then positive again, but we didn't go there. Okay, so it's the same thing.
It was crazy.
Okay, I don't think that way, and it makes me kind of crazy. So you can do slopes. So where's an inflection point?
Just
Now, if we're looking at the graph of F prime, there's no way you can give me an ordered pair, but normally an inflection point is a point, an ordered pair, but you can't.
You can make it up, you can do like one.
No, you're not gonna make it up, because you don't have that. You're not making it up. We could do that later in the course, but not now. It's at -1.5?
Yes.
Okay. And 5, probably, but we're not talking about after 5 here, okay? All right, what if I give you F double prime equation? And I want concavity. This is a new problem, yes, thank you, Eddie. Okay. New problem, I'm looking at F double prime, concave up. Or F. Important
I
distinction.
would personally do interval testing
Yeah.
at 0 and positive, or with 0 and positive.
Okay, dang it. All right. And where'd you get these?
Set x equal to 0.
The
and set x
zeros
equal
of F double prime, okay, which is what you typically do if you're finding F, then F prime, then F double prime, very good. Okay, and then you're gonna test this number, right? So this, over here, you're gonna be negative, right? Okay, and over here,
negative.
and don't forget about your quadratic. It's a parabola. It's either going to go up or down at your zeros. Okay, so where's the concave up? And then again at, okay. So I just wanted to make sure they're not always going to give you the standard F. You find F prime to find increasing and decreasing. You find F double prime to find concavity. They may give it to you some other way. Okay, so sometimes that throws people. All right, where are we? So again, okay, we already did the absolute extreme of today, extreme value theorem. So that function satisfies mean value theorem. All right, I guess we need to revisit what the mean value theorem is, since I got blank looks. No, wait for me to tell you. Thank you, Faye. It starts out with the same premise. F is continuous on the closed interval, and what's the other condition usually? Starts with differentiable. Girls, this is our premise for every theorem that we have.
Oh, wait.
Chapter 3A, 4.1, 4.2, 4.3, or 4.6, because that's what we're testing on.
There's only one value. There is at least one value that is F prime of C equals FB minus F equals B minus A.
Does that look familiar? What's that? That's the derivative at C. C is in between A and B. That's the slope at C. And what's that? That's right. And at some point, they're the same, remember? Okay. So let's find a problem with the MBT. I think there's one on this one. You can read. I'm so proud. Okay. Well, she told me she was reading. All right. Number 9. Thank you, Abby.
You just roasted people, so you take that advice too. And you just spilled your water all over your desk.
All right, I'm waiting on you to do 9 now.
Can you turn on so we can see the graph all the way?
You have it.
Oh,
on your
God.
screen.
Right with the rest of
Is it? Does it say it has like cross, then from like positive, negative, and then it crosses 0 like 3 times? That could even be
Okay, it's not crossing anything. It is, okay.
Wait.
How many times does the function h of x graph satisfy the mean theorem?
Wait, no, never mind. I was thinking it was
-6
I'll take the IBT.
to 6.
Here?
Oh, wow. You zoomed in. Oh, that's good. Okay. All right. So 6, about right here, f of 6. Okay, graph. That line has that slope. Okay? Right? That's f of 6 minus f of negative 6 over 6 minus negative 6, whatever that slope is.
I think it's -5 over 12, I think.
It doesn't matter, but
I
yeah.
think it's,
You think it's 4 times?
I do.
Okay. See if I can clone this. Will they let me? So probably right here is 1 time.
Yep.
Pulse. Here's another time.
Yep, this is all the stuff.
Okay. Here's another time.
One more.
And
Yeah.
number 4.
Yeah.
Okay. Those are all what kind of lines here?
Tangent.
No. Yes. They're this is tangents, but what are they all? Parallels. This isn't. Yes. This is not tangent. That's a secant. Yeah. That's a secant line. But all these tangent lines are parallel to the original secant.
Either it is or
no.
Which is not right.
For the right question. Okay. All right. So let's go back to the study guide. Make sure we're hitting everything here. All right. Second derivative test. Remember I said I was going to force this? Remember? Okay. Now I'm saying it again. All right. G double prime of x is 6x squared minus 2. Okay? G prime of 2 equals 0. Is 2 a local max? This is really spelled out, but I like to be so or neither. So obvious. So what theory are we using here, girls? The one you just used. The second derivative test. It's the second derivative test. Okay.
F double prime is continuous near C. If F prime of C equals 0 and F double prime of C is greater than 0, then it is a minimum.
What does this tell us?
The slope is 0.
That this right here tells us that 2 is a
Horizontal tangent. Am I right?
critical value because G prime
Is
is
it a
0.
horizontal tangent? Of F prime? Or G?
I mean, yeah, at 2 it has a 0. It has a horizontal tangent, but I don't think that's the information you want to get out of that right at the moment. So yes, that is a true statement. Okay. So second derivative test says at that critical value, if the second derivative is positive or negative, we have a local max. Okay, so now what are you gonna do? This one positive or negative? If f double prime of the critical value is positive, it's a local max or min, sorry.
Oh, it is a minimum.
Now, okay, and this one's positive? Okay, so that's your forced second derivative test, okay? If you plug in G double prime of that critical value, you get a positive number, so 2 is a local, oopsie, min, right?
Yeah. You're right.
Did I just write that wrong?
No, you're right.
Okay. I didn't mean to think you out, yeah. Okay. Alrighty then, let's see what else. Okay. Optimization, related rates, position, velocity, acceleration, those are word problems. Okay, should we grab one? Let's see, let's go back to here. I'm looking for number 3. Yes, Boolean Q, number 3. Let's see, this is at the time, assuming it roughly resembles a Q.
And is decreasing at a rate of 0.12. What is that? Its side length is decreasing? Or the volume is decreasing?
What do you think?
Oh, I don't know.
Well, only could be one thing based on its,
It's an area.
we're only talking about two
Oh,
things.
X. Great, just kidding. Doesn't have to be X.
It's a cube, it has all sides that are the same. Okay. So what do we know? What's point 1, 2? DXDT, okay, and what are we looking for? DVDT, okay.
And then one extra.
Will they sometimes give you extra information to try to trick you out?
Yes.
Like x equals 0.8 centimeters, like that doesn't matter at all.
Okay, isn't there, we have one little issue here, I do. You will? Is your bullion gets larger? Thank you. Be careful.
Negative. It's negative.
Okay, so be careful about that. Roughly represent right. Okay, how do you find the volume of the cube?
X.
Okay. So dVdt equals
3x squared.
d what?
Dx.
Okay. I knew you did. Just want to make it safe, right? Okay. And honestly, ladies, I'm going to give you points for this business. You got to write it down for me because they do that on the free response. They give you points for knowing what you know and what you don't know. Okay, let's see. So dVdt is unknown. X goes here. Don't forget the square, and negative 0.2, 1, 2 goes there. That's an easy one to solve, right? Now, does that make sense that the volume is decreasing?
Yeah.
Yes, okay. So, at what rate is the volume changing? So you would say the volume is changing at a rate of, what is it? And what's the unit?
Centimeters cubed.
Centimeters, don't forget your units.
Does it ask for your decreasing? You just in the process?
You could, they would accept either way. Honestly, I would just make sure that you probably state, because usually they tell you to interpret the answer. I would just say it's decreasing at a rate of. But if you say the word decreasing, you probably wouldn't use the negative. Okay, good question. All right. 4 minutes, okay. Good.
Let's just stop. We're all done.